Welcome back to Technical Mathematics lectures conducted by Vadhyar Online Academy. In this lecture, we will continue with integration. In particular, we will discuss about integration by parts and definite integrals. So let's get started. At first, let's see the topic integration by parts. If we have two functions u and v defined on the independent variable x, then integral of u into v dx is equal to u into integral of v dx minus integral of du into integral of v dx dx. So using this formula, we can calculate integral of u into v dx. Okay. Now, as I said, both functions u and v are functions on variable x. So when we are asked to calculate integral of product of two functions, we have to assign one function as u and the other function as v. How we have to assign u and v is based on a rule called isolate rule. Let's see that. To select which function to be u and which one to be taken as v, follow isolate rule. Here I stands for inverse function, L stands for logarithmic function, A stands for algebraic function, T for trigonometric function, and E stands for exponential function. So when we have two functions, we have to give the higher priority for inverse function, followed by logarithmic function, followed by algebraic, followed by trigonometric function, and the least priority is for exponential function. So one among the two functions has to be taken as u following the precedence given by isolate rule. Okay, let's see an example. Find integral of x cos x dx. We are asked to calculate integral of product of two functions. The first function is x and the second function is cos x. Okay, so one among these two has to be taken as u and the other one has to be taken as v. Okay, so the first function is x, which is an algebraic function, and the second function is cos x, which is a trigonometric function. So as per isolate rule, the preference goes for algebraic function. Okay, so algebraic function has to be taken as u and the trigonometric function has to be taken as v. Okay, so x must be taken as u and cos x, the second function, has to be taken as v. Okay, now let's apply the formula. Integral of u into v dx equal to u into integral of v dx minus integral of du into integral of v dx dx. Okay, so this is the formula what we have to use. So in this case, u is nothing but x and v is nothing but cos x. So let's apply these two here. So what we get is integral of x cos x dx equal to x into integral of cos x dx minus integral of derivative of u. Derivative of u, that is derivative of x, will be 1. So 1 into integral of v dx, that is integral of cos x dx dx. Okay, now let's apply integration. Here we have x into integral of cos x dx. Integral of cos x is sin x, so we get x into sin x here minus integral of, here we have 1 into integral of cos x dx. So integral of cos x dx is sin x, so we get the second term as integral of sin x dx. Okay, now let's complete the problem. Answer will be x into sin x. Integral of sin x is minus cos x. So that minus and this minus will be getting cancelled. So we will get it as plus cos x plus c. Okay, so this is the answer. Okay, so this way, by using isolate rule and integration by parts, we can solve problems like this one, where we have the given function as a product of two functions on the independent variable. Okay, now you may try to solve this problem. Find integral of log x dx. You may try to use integration by parts and you may find out the solution. Okay, now let's move on to the solution of this problem. Here we are asked to find out integral of log x dx. So this integral may be rewritten as integral of log x into 1 dx. Okay, so multiplying this function with 1 does not make any change, so we may replace log x as log x into 1. Okay, now here we have two functions. The first function is logarithmic. Okay, so this function is logarithmic, and the second function 1 can be considered as an algebraic function, because 1 can be written as x raised to 0. Okay, so as per Eilert rule, the preference goes for a logarithmic function. L has to be taken as u, and algebraic function represented using the letter A has to be taken as v. Okay, so let's apply the formula. Integral of u into v dx is equal to u into integral of v dx minus integral of du into integral of v dx dx. Okay, so here the algebraic function, which is x raised to 0 or 1, has to be taken as v, and the logarithmic function log x has to be taken as u. Okay, so therefore integral of log x dx will be equal to u into integral of v dx. U is to be taken as log x, so log x into integral of v dx. V is nothing but 1 or x raised to 0, so 1 dx minus integral of d by dx of u. U is logarithmic function log x, so d by dx of log x into integral of v dx. V is x raised to 0 or 1, so therefore integral of 1 dx dx. Okay, so this will be equal to log x into integral of 1 dx will be x, so log x into x minus integral of d by dx of log x will be 1 by x, so 1 by x into integral of 1 dx, that will be equal to 1, so 1 by x into x dx. Okay, now this x and this x can be cancelled, resulting in a value which is equal to 1. Now integral of 1 dx is x, so therefore here the answer is x into log x minus x plus c. So this is the answer. So integral of log x dx, it's equal to x into log x minus x plus c. So you may remember this as an identity. So when it comes to this kind of problems, we may make use of integration by parts. Okay, so here in place of log x, we are integrating log x into 1. Okay, so that doesn't make any difference, but we can make use of the formula given by integration by parts. Okay, so using that we can find out the solution. Okay, now let's move on to the next topic, that is definite integrals. Integral a to b f of x dx is equal to capital F of x with lower limit as a and upper limit as b, and it's equal to capital F of b minus capital F of a. So you must be familiar with definite integrals. The only difference is that here we have a lower limit and upper limit. First we have to integrate the given function, and then we have to apply the limits. Okay, let's see an example. Find the value of integral 2 to 3 x square dx. So here first we have to integrate the given function, that is x square, then we have to apply the limits. So when we integrate x square, what we get is x cube by 3 plus c. Okay, now here we have to apply the lower limit and upper limit. The lower limit is 2 and the upper limit is 3. Okay, so as per this formula we will get the answer as 3 raised to 3 by 3 minus 2 raised to 3 by 3. Okay, so the answer will be 27 by 3 minus 8 by 3, which will be equal to 19 by 3. Okay, So when it comes to definite integrals, first we have to integrate the given function and then we have to apply lower limit and upper limit. Okay, let's try another problem. Problem number 2, find the value of integral 0 to 1 by 1 plus x square dx. So we are asked to calculate the value of the definite integral 0 to 1 by 1 plus x square dx. So you may try this by yourself. Please pause the video and try to solve this. Okay, now coming to the solution, here we are having the integral 1 by 1 plus x square dx, and we know that it's equal to tan inverse of x plus c. Okay, so this definite integral will be equal to tan inverse of x plus c with lower limit as 0 and upper limit as 1. Okay, now when we apply the limits here, what we get is tan inverse of 1 minus tan inverse of 0. Okay, and we know that tan inverse of 1 is nothing but pi by 4 and tan inverse of 0 is 0. So therefore we will get it as pi by 4 minus 0, and we get the answer as pi by 4. Okay. Now let's say problem number 3. Find the value of integral 0 to pi by 4 sine cubed 2t into cos 2t dt. Okay, so you may try to solve this by yourself. Please pause the video and try to solve this. Okay, now coming to the solution, here we have to use integration by substitution also. Okay, so let's take u equal to sine 2t. Okay, so if you take u equal to sine 2t, then du will be equal to cos 2t into 2 dt. Okay, so here we have cos 2t dt, so that may be written as cos 2t dt may be written as du by 2. Okay, from this equation we will get cos 2t into dt equal to du by 2. Okay, and using this substitution we may rewrite this expression as integral 0 to pi by 4 u raised to 3 du by 2. Okay, or it's equal to 1 by 2 into integral of 0 to pi by 4 u raised to 3 du. Okay, so once we integrate this, we get it as 1 by 2 into integral of u raised to 3 du will be u raised to 4 by 4 plus c. Okay, and the limits are from 0 to pi by 4. Okay, so we have substituted u equal to sine 2t, so we have to replace this u with sine 2t, so we will get the integral value as 1 by 2 into sine 2t whole raised to 4 by 4 plus c with lower limit as 0 and upper limit as pi by 4. Okay, now let's apply the limits. So we get it as 1 by 2 into sine 2 into pi by 4 whole raised to 4 divided by 4 minus sine 2 into 0 whole raised to 4 by 4. Okay, now once we simplify this, we get it as 1 by 2 into, okay, here we have sine 2 into pi by 4, so that will be sine pi by 2. Okay, so sine pi by 2 is 1 raised to 4, we get answer as 1 here, so 1 by 4 minus, here we have sine 2 into 0, so that is equal to sine 0. Sine 0 is 0, 0 raised to 4, we get the answer as 0, so 0 by 4. Okay, so the final answer will be 1 by 2 into 1 by 4, and we get the final answer as 1 by 8. Okay, so 1 by 8 is the correct answer. Okay, now let's see another problem. The integral of x plus 1 e raised to x divided by cos square x e raised to x with respect to x is. So we are asked to find out integral of this function. So please pause the video and try to solve this by yourself. Okay, now coming to the solution, here we have to make use of integration by substitution. So the substitution is, we have to take u equal to x into e raised to x. Okay, now if you differentiate both left hand side and right hand side of this equation, what you get on left hand side will be du equal to, on right hand side when you differentiate with respect to x, what you get is x into e raised to x plus e raised to x into 1 dx. Okay, so this implies that du is equal to x plus 1 into e raised to x dx. Okay, now integral of x plus 1 e raised to x divided by cos square x into e raised to x dx, it's equal to integral of x plus 1 into e raised to x dx is du divided by cos square u. Okay, we are replacing x into e raised to x with u. Okay, so this will be equal to integral of sec square u du. Okay, so 1 by cos square u may be replaced as sec square u, and integral of sec square u du will be equal to tan u plus c. Okay, so we are getting the answer as tan u plus c, and here we may replace u with the substitution what we have. Okay, that is u is taken as x into e raised to x. So therefore the final answer is tan of x into e raised to x plus c. Okay, so this is the final answer. So that is given by option D here. Okay, now let's see problem number 5. The value of integral minus 1 to 2 x dx is. Okay, so a very simple problem. You may try this by yourself. Please pause the video and try to solve this. Okay, now coming to its solution. Okay, its answer is 3 by 2. Okay, so when you integrate this function, what you get is x square by 2 plus c, and we have to apply the limits. The lower limit is minus 1 and the upper limit is 2. So once you apply that, what we get is 2 raised to 2 by 2 minus 1 raised to 2 by 2. Okay, so we get the answer as 4 by 2 minus 1 by 2, which is 3 by 2. So that is given by option A here. Okay, so with this we are coming to end of this lecture. In lecture 25 we will discuss about applications of integration. So see you in lecture 25. Goodbye.